Welcome to Lesson 6, Applying DFMA in your design. In this lesson, we'll walk through the process of using DFMA from the concept to the detailed design. We'll also explore how we would measure the efficiency of your design using what we call assembly index. In this lesson, we will discuss the fourth step, the design step in our DMADV. We'll also do a closer discussion on applying design for manufacture and assembly in your own products. We'll describe the process by which we apply DFA and DFM from concept to the detailed design. And finally, we'll talk about analyzing the design of your DFMA using what we call a DFA index. The fourth step of our DMADV is our design. In the design stage or step, we talk about developing the detailed design out of the concept that we have started in our analyze step. The design step is where we talk about what are the important detailed ideas that would ensure that the design, product, or process will now be executed. At the design step, the product development team, in collaboration with your production team, would now develop the best concept into a detailed design by looking at the manufacturability of your design. This might mean that you have to go and look at your own processes and see how your products can be more attuned to the manufacturing processes of your production line. The team will have to ensure that the selected design can be consistently produced according to the product requirements coming from your customer. During the design step, we now develop the details of your product design and bring it down to the details of your production design. Normally, at this point in time, the design of the production can also be challenged in a way that would allow us to bring the products better to our customers. We have talked about design for manufacture and assembly in the previous lessons. Now we will go into detail how we might apply the DFM and DFA in a more systematic approach. A closer look at using DFMA means that we have to start by understanding the process by which the parts will go through. These parts can be referred to as components, or products by themselves, or components or modules of the entire product. The goal is to be able to understand how the product design can be compatible to the process that we're going to be using. Second, we'll go into the design itself of the product and eventually on the process on how we might optimize or reconfigure the design of the process in accordance to the product requirements itself. We may also look at the materials that are going to be used and how the materials would lend itself to production. Fourth, we may look into the environmental impact of our production. This might be in the context of using carbon-based fuel. It might require us to look at the sources of energy that we use or the scraps that will be generating out of the production. And finally, we have to look into the compliance of the product itself, whether we're able to produce the products according to regulatory requirements. a typical design approach would be to always start with the concept and then go into the design activities and then redesign it later on. The idea of the traditional approach is try to come up with a much perfect design as you can at the beginning and eventually try to fix it along the end. A DFMA approach is where you open up concepts at the very beginning and evaluate the concepts that you may have using the DFMA principles. By using DFMA principles, you bring forward the evaluation early on rather than later. And part of the evaluation is to check whether the concepts themselves are consistent to the DFMA principles before investing on developing the detailed design. So DFMA is really a tool to bring into the early part of your design process. So we might start with the concept design, and then we apply design for assembly, which is looking at the parts, and we look at how the parts will be made, and that's only when we pass those two sets of principles do we develop the detailed design. By looking into the concept design and factoring in design for assembly and design for manufacturability, we may ask the question on ourselves, what are the parts that we need to have? Why are they needed? Are they needed? The second question would be, how do we make the parts? How do we intend to be able to produce the parts properly? Once these questions are thoroughly explored as part of your concept to the detailed design, then the product development team can now proceed into putting in the details of their design. Looking into the other side of the diagram, we start with a design concept and then test the design concept using the design for assembly or design simplifications principles presented in the previous lesson, where we look at the product itself as a whole. Next, we look into the materials that we might use for our product and look at the parts that are needed or supposedly will be critical for the design of the overall product. Once we have that, we now proceed into prototyping and testing the manufacturability of our products, their parts, and the total product before going into looking at the production process later on. By following a process of evaluation, we now look at what the product is, going into what the parts are, and how the production can be. Using the flow chart on your left side, we can see that we start from the design concept, apply principles for design for assembly, which is basically more on the simplification of the parts and its components, looking into the materials on how we might improve the assembly using the right materials or better materials, and then we go into designing for manufacturability, which is to make sure that the ability to make these parts and eventually produce them would be consistent or compatible to your manufacturing process. Let's take an example of an adhesive tape dispenser. Looking at the right side of your table, you would notice that by designing an adhesive tape dispenser, we may begin by looking at the concept stage, where we ask ourselves on the kind of concept that we would like to have for this product. Is it a handheld? Is it a desktop? Is it something else that we wanted to start with? What would be the main body of your dispenser? Would it be plastic or cast metal? Note that at the concept step or the design, the focus is more on clarifying the product as a whole. Next, we go to the embodiment design. The embodiment design is equivalent to the parts that we talk about. What are the parts of your tape holder? Would there be a roller? Would there be a cutter? What would be the functions of each of these components? Next, how do we now choose the right materials for these components or for these particular parts? And third, what would be the way by which these parts can be made? Finally, on the detailed design, we now look at how we would actually produce these parts. So how thick the process, how thick the parts are, how many ribs would there be, in terms of the cutter, what would be the specific production specifications that you need to have so that your product now can be manufactured. In essence, when you look at the entire flow here, we now look at designing our product with an approach that's going to be guiding us to making sure that step by step, from product to part to process, we get to check the sensibility of our design as early as possible in the design concept before reaching to the actual production later on. Once you have come up with a sufficient concept of your design, you can now start to analyze how efficient your design is. One way to analyze a design with DFA is what we call a DFA index. This particular tool is applicable for evaluating the components that we have in our design and how these components might result to an efficient or inefficient way of making our products later on. Before we begin to analyze the design of our product, it is important for us to consider an existing product and perform what we call a functional analysis. The goal is to be able to establish a benchmark of the design by which we will evaluate our concept or our detailed design later on. When you choose a product, it doesn't necessarily mean your product. It can be a competitor product or a best-in-class product. The goal is to establish a baseline so that we can know how good your design is relative to what others have. Second, we need to perform a detailed product description. This means that we have to understand what are the parts, the components, how it is made, what are the materials. We need to break down the details of the product in order to be able to analyze its assembliness or its manufacturability. Third, we need to identify now measures or indicators, which we'll discuss in a little while. Fourth, we can now apply DFMA principles of simplification so that we can now understand how we might make our products better. And then finally, conduct a measurement of the proposed and then compare it to your existing or current product. A basic template for analyzing your product, the design of your product, is to be able to choose a product, disassemble it, look at the parts, and understand how many parts there are by doing an inventory of parts of each item, how much time is needed in terms of handling or maybe insertion or assembly, and what is the corresponding cost. By doing this itemized breakdown of parts, time, and cost, we get to do this not only for our own product, but also with the baseline product. Two basic questions we need to ask. Can the parts be eliminated or integrated? Can the time be reduced? Can the parts be done or introduced in a different way so that there will be less time, less parts, and less cost? So the goal of this template is that you get to do this both for your benchmark product and your own design. In order to establish a measure by which you can evaluate the efficiency or the effectiveness of your design, we introduced two basic measures. The first one is called an assembly index, which is simply a ratio of the total parts needed over the total time that's needed to assemble the parts. The second type of indicator is what we call parts count efficiency. And this is where we now have a theoretical minimum number of parts, which is the target ideal, over the actual parts that you have. The higher DFA index and the PCE measure, the better the efficiency of the design. So when you now compare the DFA index and the PCE index of your baseline product and your product, a better design should produce higher values for these two measures. Another measure for determining the efficiency of your design is a DFA index with assembly time consideration. This measure uses both parts and time, where DFA index is equal to 100 multiplied by the theoretical number of parts multiplied by the minimum number of assembly time per part and the total assembly time. By getting the ratio, we're able to establish an index where we can compare a base design and a new design, and comparing the values of your DFA index, the higher DFA index means the better your design is. Some tips when you now do an assembly analysis. Apply the design for assembly principles early on, and you can include other creativity techniques in terms of coming up with unique ideas on how you might want to apply multiple functions in a part or lessen the number of parts. You can also look into the cost of the parts and the time needed to be able to assemble the parts. By considering the cost and the time early on and how you might reduce them even in the concept stage, can provide you with an advanced view of how you can factor in those creative ideas early on instead of actually redesigning your product later on. You might also choose the best ideas from your concept by also factoring the cost and the time. One important aspect of doing the analysis is to make sure that you bring in the right subject matter experts. It's also important to make sure you bring in your suppliers, your vendors, and especially your manufacturers. They could be critical players on how your product can be better when it reaches to production. It's also important to consider benchmarking against competition or world-class products and processes. The goal is to come up with superior products, and therefore we look at those products as a way by which we compare our analysis. And finally, you can consider having cost estimation models for your products and your processes. This might mean that you have to consult with finance in coming up with the right cost model that would estimate your parts and your products when it goes through production later on. Some DFMA examples could be as follows. In terms of a product design, where we use our design for assembly, we can reduce the number of parts when possible. We can build in layers on the top, from the top to the bottom, using a gravity to locate the parts. We can have an assembled products table on work surface so that it's easier to put it together. We can have the work lie on a horizontal plane so people can see the parts and easy to put it together. We can use chamfers and fillets to ease the mating of the parts, meaning how you can put them together or mold them together or essentially stick them together. You can use snap fits for easy fasteners. Avoid the screws, avoid the glues. For the part design, which is the manufacturability, you can look at minimizing the tangling between parts in the feeders, how the parts would easily be put together in your processes. You can use a symmetry guide to reduce the orientation time during handling, which means that by putting the part, it fits in exactly. Just like a SIM card when you put in a phone. You know the slit where it should go, so you don't need to think about it. If symmetry is not possible, you might pursue other ways by which you can speed up the way the orientation can be done without the assembler or the manufacturer getting confused. This, in a way, is another way of mistake-proofing your design for manufacturing. The key learnings for our lesson here are as follows. Number 1, DFA and DFM aligns itself with the product development process starting from concept design to detail design. DFMA and DFM are not limited to being applied only when your product is about to be manufactured or handed out down to manufacturing. DFM and DFA are very valuable principles even applicable during the concept stage. Second learning, the DFA may be applied on the conceptual design during product development, involving the parts and the materials, which can lead to lower production cost even early in the design. Lastly, a DFA analysis can be done by determining the assembly index and efficiency of the product design based on the parts and the time it takes to assemble, disassemble the product for use. You can compare your analysis with a baseline product and your product to be able to determine how good your design is relative to a superior or best-in-class product.